All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 17 is on the screen. Let's get started, please. By now, we should be experts at numbers 1, 2. Number 3 is more of a review of what we've been doing with graphs and lines and all that. Just to transition to today, which is going to be our function notation and such. Okay? So, let's get started, please. Copy and go. All right, here we go. Thank you for sending that in. Appreciate it. So, being that it's Monday, I'm going to go over this one more time. See, we got it. Here it goes. First, this one. What is our dividing point? So here's 0, -1, -2. And then it's shaded to the left. Everything to the left is x. So question, what are all these numbers compared to -2? They are what? Less than. Very good. I finished your sentence. You said and. I said less than. Is this an open or closed point? Open, so we don't put an equal sign on that. Okay, let's go to the red one. What's the dividing point on the red one? 1, 2, 3, 4. Everything else is x. So what are all these? What is 4 compared to all those numbers? Less than, and it's a solid point, so we put an equal sign. When it's like this, yes. Next, look up. Do those graphs intersect? No, so it's a or, so you put or in between. And then, of course, our solution set of x such that, and you close it. Number 2, write the inverse. All right. Here we go. For the inverse, let me make some space here. All right. What is the first thing we do, people? We change f of x to what? Change f of x to y equals 2/3 x plus 5. From there, we need to leave y by itself. X by itself. So that means I subtract 5, subtract 5. We're left with y minus 5 equals 2/3 x. Next, we need to get rid of the 2/3. How do we get rid of fractions? We multiply times the reciprocal, which is 3/2. We do that to both sides. 3/2. So, we're left with x on that side. Distribute the 3/2, so that is 3/2 y minus 3 times 5 is 15/2. Are we there so far? Yes? All right. Next. Is that the inverse? Well, we already solved for x, but is that the inverse? No, we switch the variables. So there we have 3/2 x minus 15/2 equals y. And last but not least, and this is what we call the inverse, last but not least, we write it in function notation. 3/2 x minus 15/2 equals f of x. But to indicate that it's the inverse of this one, what do we use? The -1. Are we doing good? Yes, Mr. Q. All right. Number 3, write the equation for this line. So you start y equals mx plus b, y equals blank x blank. So first thing that we look for is the y-intercept, or the plus b. What is our y-intercept? Tell your neighbor. Y-intercept. Everyone. +5. That is correct. So we write +5. From there, we select 2 points on the line. So I'm going to select the y-intercept and another point. How about this one right here? That's on the line, yes? All right. So to go from here to here, that means I need to take steps down. So I go 1, 2, 3 steps. So that's -3. Make a right turn, and I do how many steps? 1. So that's -3, bless you, over 1. So my equation is y equals -3x plus 5. Send that in, please. Yeah? Is it coming back for some of y'all? Yeah? All right. Copy the agenda. Warm-up number 17 done. We're beginning our road to transformation of functions, which I trust you guys did really well at the end of last year, right? Transformation of functions. Okay, very good. Yeah. Tonight I'm going to leave you only 2 problems, and then we'll be done. So, copy the agenda. From there, make sure you go grab at least a couple of graph papers and get a Cornell note ready, please. I'll give you some time. Copy and go. Yes, Mr. Q. All right, good. All right, here we go. So, to have access to the home plate for tonight, copy that. 8H61G. 8H61G. I mean 6IG. My bad. 8H6IG. So that will give you access to today's presentation, because in there, look up, here's the home plate for tonight. Woo. Transformations, let's go. You guys feel it already? Woo. I'm feeling it. Pretty good, yeah? All right. Anyways, all right, in your Cornell notes, write this down at the bottom left of your notes. I can transform a function using different parameters. I can transform a function using different parameters. I can transform a function using different parameters. Write that down, please. All right, so we're still in the functions main concept, yes. And today we're going to begin transformations, and we're going to be using something called parameters. Now, in the past, maybe you kind of struggled with these, so hopefully I do tic-tac-toe all this, so like that you guys can get it from the very beginning, because we're about to embark in a lot of transformations. Yeah. Let's go! Transformations. Bring it. Yeah, I'm ready to go. So, with that said, we already covered all the basic stuff. We did a lot of equations and inequalities. We focused on domain and range, different notations. I did a formal introduction to functions. We did linear functions by graphing lines. Today we're going to continue a little bit of that, but we're about to embark on quadratic and cubic functions, little by little. All right? Yes, Mr. Q. All right, good. So, with that said, look up to the screen. Don't copy this. So, by now we know what functions are. Is that correct? So, not possibly, now you are experts at this. So let me show you a non-example. A non-example. 2, 3, 1, 5, 7, 11, 7, 11, and then 1, 9. Tell your neighbor why this is not a function. Why is this one not a function? Why is that not a function? Talk it over to your neighbor. All right. Looks like Dayali's got it. Very good, Dayali. Miguel's got it. Very good, Miguel. Hyman, I see you. Michelle's got it. Scarlett's got it. Very good. Victoria's got it. Very good, Victoria. So let's go with Leo. Why is this one not a function? Because 1 is repeated twice. Hold on, let me highlight that. Look up. 1 is repeated twice, comma. It has 2 outputs. It should have a 5 when it repeats. Is that correct? Does it have a 5 here? No, that is not a function. So therefore, look up. 2, 3, 1, 5, 7, 11. Tell your neighbor what I would write here to make it a function. What would I write there to make it a function? All right, we good? All right. What would we write there? Let's go with Leo, pass someone. Julian, what would we write there? 2, 3. Okay, hands if you agree with that. Yeah. To repeat it, if it repeats, we need to have the same outputs. Who was thinking 1, 5? Some of you, yeah. But could it have been 2, 3? Yes. Could it have been 7, 11? Yes. As long as the same output is when the same input is repeated. All right. So we took notes on that. We know what functions are. So this is where we're going today. Look up. Today we're introducing something called a parameter. Don't write this down. Just pay attention. Mr. Q, what are parameters? Well, they were introduced last year when you guys did transformation. So think about it. Parameter. Let's see if I remember. Parameter. Oh, I remember. You guys remember? Yeah? But anyways, parameters are numbers that change a function to another function. Let me repeat that again. Parameters are numbers that change a function to another function. All right? I'm going to be reintroducing that today. So, look up. Where have we been? Have we been using y equals something, something, x, something, yes? And then we changed the y to what? F of x. And the only thing is just changing the label. And why do we change the label? Because we're no longer in linear equations. Now we are in function, linear functions. That's why we use f of x. F stands for what? Function. And that's what we're going to be using today. So, to get us going, on the graph paper, go to the back side to the little ones. Go to the top left. And I want you to write example Q. And it says graph f of x equals 3x minus 1 using domain -2, -1, 0, 1, 2. And then I want you to make three tables underneath. This one in black, look up. This one in green if you have green. And this one in red. So copy those. On the top left of your graph paper, you have plenty of space, yes? I'll give you guys some time. Copy and go. All right, here we go. It says graph f of x equals 3x minus 1 using the domain -2, -1, 0, 1, and 2. Now, I've given you plenty of practice on the previous warm-ups on how to evaluate functions. So let me make some space on the left side. All right. So I'm going to start off by filling in this table right here in black. Y'all ready? So instead of x, I'm going to start by using what value? -2 inside here of the function. So I'm going to write it out. F parentheses equals 3 parentheses minus 1. So my first value is -2. Are we there so far? Okay, so we're going to, some others, possibly, no, yes, very good. So now we're going to work on the right side. The left side is only a label, yes? So the right side, what is 3 times -2? That's -6. Minus 1, that's what? -7. Do you fill that in the table? Let's do it again now for the -1. So F blank equals 3 blank minus 1. So now I'm going to write in the -1. -1. Once again, the left side stays the same. The right side, I work it out. What is 3 times -1? -3. What is -3 minus 1? -4. All right. Finish the last 3 of them using that function. What is it? Oh, my bad. Hold on. Let me move it over because some of you can't see. Is that better? Yeah. So the left side stays the same. 3 times 0 is 0. What is 0 minus 1? Negative 1. Do it again. F of 3 parentheses minus 1. Next value is 1. 3 times 1 is 3. What is 3 minus 1? That is 2. And the last one, F of equals 3 parentheses minus 1. My last value is 2. 3 times 2 is 6 minus 1. That is 5. And once again, remind your neighbor why we don't do anything on the left side. Why don't we do anything on the left side? Because it's only a what? A label. My goodness. All right. We good? All right, let's graph that. Negative 2, negative 7. Negative 2, negative 7. Negative 1, negative 4. 0, negative 1. 1, 2. And 2, 5. And make sure you put arrows at the end. And we're going to label this one F of X. Now let me pause the music and let me elaborate on this. From now on, when I ask you to graph the original function is known as F of X. Anything after that, we're going to label it G of X. Just so that we can indicate that it changed. Are we there so far? All right. So now that I have that one, let me use the second table. So writing utensils down, let me show you how to fill in the second table. Pay attention to this part. Here it goes. Writing utensils down, look up to the screen. Ready? Put away those mobile devices or I'm going to take them away. Last call on those mobile devices. Here it goes. Y'all ready? All right. Here it goes. The second table says, same input, negative 2, negative 1, 0, 1, and 2. Is that the same as this? Yes. But the second part says, take what f of x was and add 5. So let's go with the first value, negative 2. What was f of x? Negative 7. If we add 5, that gives us negative 2. Fill that in, please. Next, let's do it again. At negative 1, what was f of x? f of x was negative 4. Well, if we add 5 to negative 4, that gives us what? Positive 1. Next one, at 0, what was f of x? f of x was negative 1. So what is negative 1 plus 5? Positive 4. Next, 1 was 2. 2 plus 5, that is 7. And the last one, this was 5, and we add 5, that gives us what? 10. All right, let's graph that. Negative 2, negative 2. I'm going to do that in green. Negative 1, 1. 0, 4. 1, 7. And 2, 10. That one is in green, or if you have a different color, that's fine. Arrows at the end. And I'm going to label that. Do we label it f of x? No, because we already changed f of x, so this is g of x. G of x. Because we did something to the original one. So now, earlier I said a number that changes a function to another function is known as a parameter. So what was the parameter for this one? Plus 5. Are we there? Okay. So now check this out. Let me show you something. Y'all ready? All right. Writing utensils down, look up to the screen. Here it goes. If I was to say that something happened to this one so that I can bring it over here, look at the 5 points. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Imagine somebody walks in right now. Let's see. Do you guys have a little person in your life? Some of you? That always bugs? You're eating hot Cheetos or Takis, they take them away, right? They're like, I want Takis. Or if you're playing your game, right? You're gaming and they want a game as well. All right. Let's say they walked in and they saw the f of x. What would you tell them happened f of x without explaining all the numbers? What happened from f of x to get to g of x? Talk it over your neighbor. What happened from f of x to get to g of x? Talk it over your neighbor. What would you say in their words? What happened to f of x to get g of x? Talk it over your neighbor, and then Victoria is going to enlighten us. Talk it over your neighbor. What happened to f of x to g of x? What happened? Leo, get the light, please. What happened to f of x to get g of x? All right, Victoria, what happened to f of x to get us g of x? You added 5. Okay, that is correct. Technically, yes. However, I said without using those numbers, I said, what would you tell them happened to the black one to get to the green one? Tell your neighbor, what would you say you did to the black one to get to the green one? Miguel, what happened? Yes. To get from the black one to the green one. Go up how many? Everyone. 5. That is correct. Write that down, please. Go up 5. And I want you to point to this part. Does that make sense? Yes? Now check this out. Without filling in this table, look up. Without filling in this table, I want you to graph me f of x minus 2. So f of x is the black one. Where would I move the 5 points to get our new function? Do that by yourself, please. So f of x. It says f of x. All right. So Miguel said for the green one, it went up from the black one to the green one, it went up 5. And we saw here plus 5. So what happened to your red one from the black one? Miguel, pass someone. Tell your neighbors really quick, and then Miguel's going to pass someone. What happened from the black one to the red one? Tell your neighbor, please. Miguel, pass someone. Julian? Julian, what happens to the black one to get now the new red one? Went down 2. So the 5 black original points go down 2. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. And we're going to label that g of x. Why not f of x, Mr. Q? Because f of x is the original one. Okay? So, can we write our points here? Yeah. Negative 2 is what now? Negative 2 is negative 9. It's right there, yeah. Negative 1 is negative 6. 0 is negative 3. 1 is 0. And 2 is 3. From 1 to 5, how comfortable are you with that so far? Where are we at? 5, 5, 5. We got it, right? Is it coming back? Hopefully. For those of you that didn't see it before, hopefully this is helping you to transition to the movement of that. So, look up, please. So if I was to say, let's do a conclusion, look up. Let's say I gave you the form g of x equals f of x plus k. Look up, please. K being our parameter. So somebody walks in and you said, in order to get a new function g of x, I take f of x and I add k. So what would you tell somebody walking in that k does to the entire function according to what we did there? Talk it over to your neighbor. What does k do to the function according to what we just did there? What does k do to the function? Tell your neighbor. All right. Looks like Yaretsu's got it. Very good. Sarah's got it. Very good. Let's go with Jaime. What does k do to the entire function? It transforms it in, but what does it do to the original one? It moves it in which direction? Up or down. So write this down. G of x equals f of x plus k. Up or down. If it's a positive number, it moves up. If it's a negative number, it moves down. That is correct. Send me your notes on the screen, please. Your copious notes. All right. Let's see how well we do with that. Look up to the screen. Let's say I gave you this. How many points do you see? 4, okay? And let's say I call this, since it's the original one, what are we going to call it? F of x. That is correct, okay? So, check this out. Get a graph paper in front of you. Plot this. Graph it. And label this one f of x. So, according to what I give you here, in green it says, I want you to graph me g of x, which is equal to f of x plus 4. And in red, you're going to graph g of x, which is equal to f of x minus 4. It's on your screen. All right, should be just about done. Show your neighbor what you did with the green one and with the red one. Show your neighbor what you did with the green one and the red one. All right. Everybody showed their neighbor? All right, good. Let's go with Natalia Espino. What do I do to get the green one? What do I do to the original one to get the green one? 4. Go up 4. So we go 1, 2, 3, 4. This one, 1, 2, 3, 4. This one, 1, 2, 3, 4. This one, 1, 2, 3, 4. And we label it what, everyone? G of x. Hands if you got that. All right. How about the red one? What happens to the red one? Everyone? It goes down. That is correct. So we go from the black one, we go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And again, we label this G of x. Are we doing good? All right. So from 1 to 5, how come to are you with k so far? Yeah, 5, 4, 5, 4. We got this, right? All right, I'm about to introduce another parameter. Oh yeah, I got this. So, go to your new graph paper, a new one. You worked on 3 of them already, yeah? On 2 of them? All right, let's go to a new one. And on the left side or the right side, I want you to write example super Q. And it says, graph f of x equals x squared using the domain -2, -1, 0, 1, and 2. And again, let's do 3 tables, 1 in black, 1 in green, and 1 in red. Copy that. I'll give you some time. No? All right, for the sake of time, I'm going to make some room on the left side so that we can do the work for the first table, just like what we did with the other. However, if you notice now, it has a square, yes? So students, quadratic functions, students. All right? Like I said, you guys should have covered this last year. We'll get to a formal introduction. Right now I'm doing a smooth introduction. All right? So I'm going to take f of x and x squared, and I'm going to write it next to the first value of -2. So f parentheses equals parentheses squared. Okay. So my first value is what? -2? -2, the left side stays the same. So what is -2 times -2? Positive 4. Let's do it again. F blank equals blank squared. The next value is -1. Once again, the left side stays the same. It's only a label. So what is -1 times -1? 1. F of parentheses squared. So now it's 0. 0 squared is 0. F of 1 equals 1 squared, which is 1. And f of 2 equals 2 squared, which is 4. We good? All right, let's graph that. -2, positive 4. -1, positive 1. 0, 0, 1, 1, 2, 4. You're like, oh, snap. I remember these. Woo-wee. Label this one what, everyone? F of x, because it's our original one. That is correct. All right, here we go. Go to the green one. You're like, oh, snap, Mr. Q, this looks a little bit different. Yes, it does, doesn't it? This is, now it's inside of the parentheses. Let me go back to the previous one. Let's see. The previous one, hold on, was outside of the parentheses. Oh, okay. This one is inside of the parentheses. Okay, so what do we do, Mr. Q? So basically, instead of just taking -2 squared like this one, we do -2 minus 5 squared. Everybody see that? -2 minus 5 squared. So, you're like, wait a minute, but this is a 3. Oh, okay, so check this out. What is 3 minus 5? -2. What is -2 squared? That is 4. Let's do the next one. The next one is what? 4 minus 5. What is 4 minus 5? -1. What is -1 squared? 1. What is the next x? The next x is 5. What is 5 minus 5? 0. What is 0 squared? 0. Next one, 6. What is 6 minus 5? 6 minus 5 is 1 squared. What is 1 squared? 1. And last one, 7 minus 5. 7 minus 5 is 2. What is 2 squared? 4. All right, so let's graph this. 3, positive 4. 3, positive 4. 4, positive 1. 4, positive 1. 5, 0. 5, 0. 6, 1, 6, 1. And last one, 7, 4, 7, 4. Graph that. And what do we label this one? G of x. All right. Now check this out. Look up to the screen. Writing utensils down. So look, the original one was f of x. However, this one, look up, we have f, and then we have x minus 5. So if you were to tell your little person, what did we do to the original 5 points to get to here, what would you tell them? Talk to your neighbor. What would you tell the little person that we did to these 5 points to get to there without talking about numbers? Talk to your neighbor. What would you do? All right. Leo's got it? Yeah. All right. Gloria, what do we do? Move to the right. Move to the right. So make a label. Move right. How many times, people? 5. So, without filling in this table, look what this one is giving us. If this was x minus 5 and it moved to the right, tell your neighbor what this is going to do to the original ones and sketch it. Talk to your neighbor. What is that going to do? Renzo, what is that going to do? If this one was x minus 5 and it moved 5 to the right, this one to the left, 4 steps. 1, 2, 3, 4. And we label that g of x. So this is a different parameter. We call this parameter the h parameter. H parameter. All right? So, write this down. G of x equals f parentheses x minus h plus k. This is going to be our bread and butter from today on. So we said that k moves it what? Up if it's positive, down if it's negative. Which means k is going to move it to side. Now check this out. If it's a negative, it's going to move it to the left. If it's a positive, it's going to move it to the right. And you're like, Mr. Q, wasn't it the opposite? Yes, how it looks, but we'll talk about when we get there, when we see it already in action.